30-minute step-by-step manufacturing process of a FiberForce CST framework. The manufacturing process of a FiberForce CST framework has been developed to obtain a highly resistant, anesthetic, implanted self-supporting acrylic denture, which doesn't require standard metal reinforcements. Precautions. A three-dimensional fiber structure is easily manufactured using light-cured fiberglass braids which are securely fixed around implant pillars. The positioning of the reinforcements has been studied by our engineers to minimize any fracturing of the acrylic resin even when off-center stress loads are applied. The strength of the self-supporting structure once it is incorporated within the acrylic resin is dependent on the protocol being followed closely. Preparing implant pillars. Trim the pillars to the required height. Sandblast the pillars using aluminium oxide. Apply a silane and leave it to dry. Coat the pillars with a dental adhesive. Preparing the framework for the bridge. If a distal extension is necessary, using a burr fissure drill, drill a 3 or 4 mm deep cylindrical hole in the plaster. The maximum distance from the distal implant is 11 mm. Fill the hole with pink BioFlow light curing resin and insert an extension pin post. Position the right and left tension pins. The tension pins enable the fibre reinforcements to be placed under tension. When a distal extension isn't required, the right and left distal implants must be secured by a double wind. A single wind used around a tension pin is not sufficient in this case. Light cure with an appropriate handheld lamp. Blue light maximum absorption is reached at 460 nanometers. Creating the framework of the bridge. Lower reinforcement row. Begin by attaching a 450 mm length of a hybrid 1:6 braid to the right tension pin with a clip avoiding the mucus support. Wind the braid around the base of the right tension pin and light cure or hold in place with the clip. Keeping the braid taut, wind it once completely in an anti-clockwise direction around the base of the first pillar and repeat the process around the second pillar. Light cure the positioned braid, avoiding the rest of the braid. Then repeat this whole process until the left tension pin has been wound and light cured. Middle reinforcement row. Continue with the second reinforcement row by winding the braid in a clockwise direction around each pillar, working towards the left tension pin. Ensure the braid is kept taut at all times. Light cure the braid on every second pillar as before. Upper reinforcement row. Keeping the braid taut, create an upper reinforcement row by repeating the winding of the pillars and the light curing of the braid, finishing at the left tension pin. Holding it at approximately 45 degrees, pull it towards the first pillar, and then light cure the whole framework. Stabilizing reinforcements. These reinforcements are used to hold the acrylic resin perfectly in place even when off-center stress loads are applied. Begin with a 300 mm length of a 1:4 hybrid braid at the base of the tension pin. Holding the braid taut, wrap it around the reinforcement rows of the first structure, firstly from left to right, and then back along the structure from right to left, making sure the lines of braid cross over one another. Put the Fiberforce CST framework in a light curing unit, respecting the recommended photopolymerization time. Using a disc, cut away any ends of fibre. Cut the tension pins at their base. Setting the structure in the acrylic resin. Proceed in accordance with protocols practiced in your laboratory. Make sure the whole Fiberforce CST framework is immersed in the resin. The reinforced structure is compatible with all available resins. It can be used with all moulding procedures such as injection, compression and cold moulding, and all types of light curing.